I'm Carter,
Sydney.
I'm Lil.
and today we're going to be demonstrating how to make bootstrap confidence intervals in R for both a single mean and a difference in means.
So for the single mean, we're going to be using the mean of white wine. And for our question, it's going to be, what is the 95% confidence interval for the mean acidity level of white wine? And for the difference in means, this is going to be the mean difference of white and red wine. And for our question, it's going to be, what is the 95% confidence interval for the mean difference in the acidity levels of red and white wine? Or we can say, how much more acidic is red wine than white wine on average?
Yeah, and just to give a little bit more context as to like what the whole goal is. So we're taking data sets that of red and white wine, and essentially by doing the bootstrap confidence interval, we're trying to find what the true mean is that can be like kind of placed on the population as a whole. So the bigger the data set that we have, the more information we have, and then the better our confidence interval will be. Vice versa, the less data in the data set you have, the worse estimate you'll get, essentially. So we're trying to find the real mean of white wine and the real mean difference of red and white wine for the population. So then we can get into our exploratory analysis, where we took the two data sets, and we're actually not merging the data sets this time. So we're getting our data from these two files. So we have red wine and our white wine. And then we are going to just kind of summarize it so that we can see it a little bit better. So by doing the box plot, we have white wine first and then red wine. So here we have our white wine box plot, and then here's our red wine box plot. So we can see that when we compare the two, we're gonna kind of assume and that red wine is gonna have higher acidity levels than the white wine. So then we can also look at a summary of these two just to put some numbers to the box plots. So the median line that we saw for white wine was 6.8, and then the median for the red wine was 7.9, which follows what we saw in the pictures, which has red wine as higher in its fixed acidity. And then just to look at the column names that are going to be present in both of the data sets, we have all of these different measurements of the wine, and we chose to look at the fixed acidity, which is measuring taric acid in the wines, which is generally produced in fruits like grapes. So that's what we are going to be looking at.
So now that we have our basic wine data entered, we can start looking at our for loop for our single mean. So first off, we'll set seed as 1, 2, 3, 4. This just makes our data replicable, so we can repeat it and get the same randomly populated data each time. We made vector sample size. This is the length of our white wine fixed acidity, or our number of entries in fixed acidity. We made vector m. We just made this a large number, 10 to the 4th. This is in our for loop, how many times our for loop runs. Then we made vector my means. This is the vector that gets populated in the for loop. And we put a 0 in there as well, just to know that if we get a 0 back, we know that it did not populate correctly. Yep. So in getting into our for loop, I and 1 through m, so it runs m times. We have vector my samp. So this takes a sample. So it takes entries from white wine fixed acidity. Number of samples it takes is the sample size, and replace is true, meaning that since the sample size and the white wine fixed acidity are the same length, some entries might not get represented, as others might get represented 2 or possibly 3 times.
We can just do this example to try and get a replicated. So here we got 2 2s, therefore, well, actually, we should probably, to make it even a better, since our sample size is the same, we should do 5 here. So here we can see that 1, 2, 3 were not represented because 4 was represented multiple times.
Yeah, perfect. And then So then that's my samp, and then the mean of my samp goes into the vector my means, which is the one that gets populated in the for loop.
And then every time the for loop runs, this ticker and I will count up, and then a new mean will be inputted until we have a full, like, my means vector.
Yes.
So let me just run this all the way through. Takes a second. We could start talking about the quantile maybe.
Yeah, so then going down, we'll look at a histogram. We'll also look at a quantile. Let's see if we can get that.
Okay, so here's our histogram.
Yeah, so there's our histogram of our my means, so the newly populated data set for the fixed acidity. We will also be looking at the quantile of my means. So what the quantile is pretty much, and we have a good graph here to kind of show it. It'll take our two bounds, which we put in, which were 0.025 and 0.975. So 2.5%, 97.5%, as these are the two lines on the side.
Yeah, so it's measuring from here to here, and then from here to here.
Yes.
Yeah.
So then that puts 2.5% on both tails, meaning that we know there's 95% of our data in the middle, which gives us that confidence interval of 95% there.
Yep, so then the confidence interval will measure what data set or what data point is on each interval or quantile bound, so that 95% of the data is in the middle of them. Go back to R here. So then I can go into kind of the conclusion. We have the data copied right down here, so we can see that our lower bound is 6.83 and then our upper bound is 6.87. So essentially what this is saying is that we are 95% confident that the true mean acidity of white wine is between 6.83 and 6.88 grams per liter. And you can notice that they seem very close, but when we look back up at our sample size, we have a very large number of data sets or data points. So this makes us way more confident that we're going to be able to create a confidence interval to show the real mean. So the larger the data set, the more confident we are about that it will like replicate the real mean. So therefore it can give us a much more close confidence interval.
Yeah, so now getting into our double means, which is comparing red and white wine. Kind of go to the same thing as we did before. We'll set seed 1, 2, 3, 4, make sure the data is replicable. We'll make the vector red samp size, which is the length of the red wine fixed acidity, how many entries we have in that, as well as white samp size with the length of the white wine fixed acidity. Keep m the same, 10 to the fourth, how many loops we do in the for loop. Keep my means, which is a vector that will get populated in the for loop. And going into the for loop, this time we'll have two samples in there. It'll be red samp and white samp. Both will sample from their respective fixed acidities. It'll take same number, red samp size, white samp size, as well as the replacement in there as well. Then going into my means, which is a vector that's getting populated, we'll take the mean of red samp minus the mean of white samp, giving us the mean difference in acidity for those two newly populated vectors.
And then just in case anyone's curious, we don't really care if they're the same size because we're taking the mean first. So that's why we don't need to really worry about if they have the same number of samples or sample size.
Yeah.
So we can run this all the way through. And it takes a second. But again, for this one, we're trying to find the 95% confidence interval. So that is why we did 0.025 and 0.975. So then here's our histogram. And then it will have the confidence or the quantile, which is the same as what we have right here. So for our 2.5%, boundary, we have 1.378, and then our 97.5% boundary, we have 1.55. So this is saying that we are 95% confident that the true mean difference in acidity for red and white wine is between 1.38 and 1.56 grams per liter. Or another way we could say that is that we are 95% confident that on average red wine is 1.38 to 1.56 grams per liter more acidic than white wine. And then we can also show this as a ratio by just changing this minus to a division sign. And then it'll show us how much more acidic red wine is than white wine in terms of a percentage. So we can let that run, but we already have the data put down here. So it says that our 2.5% boundary is this 1.20, and then our 97.5%, here it popped up, our 97.5% is 1.227. So essentially what this is saying is that we're 95% confident that on average red wine is 20.1, which we got from this section here, to 22.7% more acidic than white wine.
So for our summary, we took 2 data sets and compared their box plots, and then we took 1 data set, which was the white wine, and did a Bootstrap confidence interval to find the true interval of mean acidity with a 95% confidence level. We then wanted to see how red and white wine acidities compared, so we took both data sets and did a Bootstrap confidence interval to find the true mean difference interval with a 95% confidence level. And for some context, wine acidity plays a key role in how the wine feels on the tongue. The greater the acidity, the more crisp, but the lower the acidity will feel, so lower acidity will feel smoother on the tongue. And just to look at some examples of other acidity levels, apple cider vinegar has a 0.68 gram per liter acidity level, and orange juice is 0.409 grams per liter.
Then a lot of people think, like when we talk about acidity, that they're like, oh, well, what about vinegar? But it's important to note that the acidity that we're measuring is fixed acidity, so non-volatile, and specifically we're looking at the tartaric acid, which is produced from fruits. So in vinegar, there's not a lot, it's not based off fruit, therefore it's very, very low in terms of that type of acidity. So that's all we got for you in terms of how to do a Bootstrap confidence interval.